This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Our next example here, example 3, is to find the equation of the circle with centre 3 minus 4 and contains the point 2, 3. So our first big ask is to find the radius, because we have our centre 3 minus 4, but we don't have our radius, which is what we need to write down our formula. But to get the radius, we know that we have a centre of 3 minus 4, 1, 2, 3, 1, 2, 3, 4. So our centre is here, and it contains the point 2, 3. So 1, 2, 3, point 2. So our circle looks something like this. But to find our radius, we need to look at the distance between our centre and any point on the circle, because the radius is always the same no matter what part of the circle you look at. So if we let this distance be our radius r, we have the values of our 2 points, 3 minus 4 and 2, 3. So we can use our distance formula to work out our radius. So our distance formula, you'll recall, is the square root of x1 minus x2 squared plus y1 minus y2 squared. So in our case, our x1 will be 3, our x2 will be 2, our y1 will be minus 4, our y2 will be 3. Filling those values in, we get this line over here. And if we work out this, we have 3 minus 2, which is 1, which is 1, squared is just 1. So that's equal to the square root of 1 plus minus 4 minus 3 is minus 7, and minus 7 squared is plus 49. So we get our radius is square root of 50. And then we can just fill in our formula as before. So our h is 3, so it's minus h, so minus 3, x minus 3 squared plus y plus 4, because our k in this case is minus 4. And our r squared will be square root of 50 squared, which is just 50. So that is our r squared, is 50. So the equation of our circle then is x minus 3 squared plus y plus 4 squared equals 50. Now I'm just going to take a look at a question at higher level. So we're asked to find the equation of the circle with centre minus 3, 2, and having the line x minus y plus 4 equals 0 as a tangent. So we have our centre, so we can fill those numbers into our formula for our h and our k. but we need to find our radius. So again, we're given a tangent. So the distance between the perpendicular distance from our center at minus 3, 2, perpendicular distance from that point to this tangent will be the radius of our circle R. So we're going to have to use our perpendicular distance formula again. And if we look at our various components, we can see that in our case, the equation of our tangent is x minus y plus 4 equals 0. So our a is the number in front of x, which is 1. Our b is the number in front of y, which is minus 1. And our c is our constant, which in our case is plus 4. Our x1 is the x-coordinate of our center, minus 3. And our y1 is the y-coordinate of the center, 2. Filling all of those values into our perpendicular distance formula and simplifying the top and the bottom, we find that r is equal to 1 over square root 2. The perpendicular distance gives us our radius r. So then it's just a matter of plugging these values into our general equation, which we recall is x minus h squared plus y minus k squared equals r squared. So minus h will be equal to minus 3, which is plus 3. So that's why it's x plus 3 squared here. Our minus k is just going to be equal to minus, our k is just 2, so we have minus 2 here. And our r was 1 over square root 2, so we'll have 1 over square root 2 all squared. Simplifying all that out, we get our final equation, x plus 3 squared plus y minus 2 squared is equal to a half. And that's the equation of the circle we're looking for.